Domain and vertical asymptotes. A rational function is a function of the form f of x equals n of x over d of x, where n of x and d of x are polynomials. Here is the graph of f of x equals x plus 3 over x plus 2. So this is what a rational function looks like. Okay, there's different variations on this, but basically you're going to notice that it's going to have a break in the graph where you have a vertical asymptote. Okay, and so this vertical asymptote, remember, is a line that the graph does not cross. Okay, so that means that this point on the x-axis will not be included in the domain because the graph doesn't touch it. Will not be included in the domain. It's also the number where you have a vertical asymptote, a line of undefined slope. The domain of a rational function includes all real numbers. Notice it goes infinitely to the left and it goes infinitely to the right. So all real numbers except x values that make the denominator 0. Again, except x values that make the denominator 0. Okay, what would make the denominator of f of x equal to 0? What do you think? What would make this 0? What value of x? Hopefully you said -2. -2. The math, if you can't do that in your head, the math for finding that number would be to take the factor and set it equal to 0 and then solve for x. This process gives you the vertical asymptote. Okay? It also tells you the exception for the domain. If f of x is equal to n of x over d of x, and n of x and d of x have no common factors, so no common factors, okay, the factor on the top would be -3. Okay, you would set that equal to 0 and solve for x, so -3, -2, so they're not common. Okay, then the graph of f of x has vertical asymptotes at the zeros of d of x. So d of x, remember, is the denominator. They use d for denominator and n for numerator to distinguish between the two polynomials. Okay, it says, what are the vertical asymptotes of f of x? Well, here it is. X equals -2. Remember that when you have a line that starts with x equals, remember that that represents a vertical line. Okay, and since it's an asymptote, you know, we use a dashed line. So we have a vertical line that's dashed, represents an asymptote, and goes through -2. So looking back at the graph, -1, -2, we draw in our vertical asymptote at -2, and then there you can see it. Now, before I move on, if I want to write the domain for this, we're going to write it like this. We're going to say that the domain is going to be all real numbers, so let's use set notation here. So x is going to be an element of all real numbers, okay, such that x does not equal -2. Okay, so all real numbers except x does not equal -2. And that's how we would write the domain for this function. All right, let's see some examples here. It says, identify the vertical asymptotes of the following graphs. Well, all you have to do is really look for where the graph breaks apart into two. And so if you look for where the graph breaks into two, you can see there's a line right here that goes directly in between the two parts. So we have a vertical asymptote at, and you look for the number on the x-axis, so that's going to be 1. So our vertical asymptote is x equals 1. Our domain is going to be x is an element of all real numbers such that x does not equal 1. 1 is not in the domain. Okay, try number 2 on your own. Number 3, notice we have 2 breaks. We have a break here in the graph, and we have another one here. So our vertical asymptotes, there's going to be more than one. We have -1, -2. So we have a vertical asymptote at -2, and 1, 2, 3. So there's your 2 vertical asymptotes. Domain, x is an element of all real numbers such that x does not equal -2, okay, or 3. It says match the graphs with the rational functions. So what you want to do here is you want to find the vertical asymptotes of each of these functions and then pair them up with the vertical asymptotes with these graphs. So do you remember how to do this? If you look back at your notes, okay, it says, what would make the denominator of f of x equal to 0? So remember how I took the denominator, the polynomial in the denominator, I set it equal to 0? That's what we want to do. We want to take the denominator function, which is x, set it equal to 0. Okay? And notice the factor on the top, this would be with -1. Okay, so they're not the same, so always check that. Okay, because there's a special situation that happens when the factors are the same, they cancel out. Okay, so here we go. So the factor on the top is -5. Okay, this factor is going to be, set the two factors equal to 0, and we get x equals 3. That's going to be one vertical asymptote. X equals -2. So this function is going to match, we're looking for -2 and 3. There it is, -2 and 3. So this function here is going to match number 3. Okay, so figure out which graph this one matches and which graph this one matches, and put the two numbers down here, please. Okay, moving on. I know this is a long video and I said I was going to start chunking them, but this is new material, so I have to go through all of this. It says state the domain and find the vertical asymptotes for the following rational functions. So we want to, again, to find the vertical asymptote, we take the denominator, the function, the polynomial in the denominator, and set it equal to 0, and then solve for x. So there's your vertical asymptote. And then the domain, okay, since we have a asymptote at -2, that means -2 will not be included in the domain. So x is an element of all real numbers such that x does not equal -2. It is not part of the domain because there's a vertical asymptote there. Now in number 5, we can go ahead and set that equal to 0, okay? And then solve for x. We can do that, no problem. Or we could factor it out and set each factor equal to 0. But since there's no middle term, there's nothing that prevents us from just solving it. So adding 4 on both sides. Okay, square rooting both sides. So we have x equals plus or minus 2. So we have a vertical asymptote at 2. Oops. Wrong way. And we have 1 at -2. Okay. Now let's go down here to number 7. Let's review on these problems here. You're going to want to factor it. So remember to factor. You look to see if you can factor out a common factor. So notice that both of them have an x. So we can factor out an x. So we end up with x factoring out an x plus 3. Then we have to set each factor equal to 0. So we're going to have a vertical asymptote at x equals 0. And then x equals -3. So those would be your 2 vertical asymptotes. Okay. Another little reminder, how do I factor this? In case you forgot, you can go ahead and factor this using the x factor, or you can do it in your head. Since the a value is 1, so 1 times 3 is 3, and then the 4 goes on the bottom. So remember that we want two numbers that multiply to give us 3 and add to give us 4. So obviously it's going to be 1 and 3. A value goes on top. So 1x plus 1, 1x plus 3. So we have a vertical asymptote at -1 and a vertical asymptote at -3. Same thing for this. You're going to need to factor it, and you're going to need to use your x factor to do that as well. So give these a try. If you feel like you need to practice, if you got it down, then you're good. All right, I tried to keep this as short as possible. So if you have questions, I will answer them on Monday. Hope you're having a good weekend.